Diatomic molecules are like pairs of shoes in your closet. Girls tend to have more shoes than guys, right?
No.
Yeah.
No?
I like you, Josh Trim.
Josh Krim has a lot of shoes, doesn't
He does have a lot.
he? How many shoes does Josh Krim have?
Does anyone know how many shoes he has?
He has a bunch, huh?
20 pairs.
20 pairs? Oh, I bet you there's some girls that got more than 20 pairs.
I only have sneakers with
Do you have more than 20?
us.
All right. For some reason, I don't know what, but girls really like shoes. All different types of shoes. And that's fine. Okay? If you're like me, a guy, 2 shoes, you're good. 2 pairs of shoes, you're good. Maybe dress shoes.
Don't let him fool you. He has way more than just 2.
What's that? Me?
Yeah, you have way more than just that.
No, I have 3.
Alright.
And these. And I have another dress pair, and I have tennis shoes. Oh, I have some wrestling shoes.
Okay, that's.
And then
4.
I have the other shoes and then some
Huh?
other shoes.
You
No.
don't like slippers or sandals or anything?
Yeah, like what about during the summer?
Well, those aren't shoes, are they?
Yes, they are. They're
No.
shoes. Those are definitely shoes.
Okay.
Shoes.
Maybe a few more, but
Guys don't.
But sandals,
Wear them on your feet, they're classified as shoes.
even like slippers. Slippers are shoes. I say shoes are something you can wear to work or wear out to work. All right, so I might have a few more. Not very many though. When you go get your shoes, there's always 2. They're always paired up. These elements, when they are mixed together, they naturally pair up. They covalently bond together. So oxygen's a double bond. They double bond together, oxygen does. Okay? Nitrogen triple bonds together. Chlorine will single bond together. So oxygen in this room that we breathe in is O2. Nitrogen we breathe in is N2. We just don't use it. Okay? But there are certain elements. It's the halogens. If you would go down your halogens, they're all diatomic. Okay? Kind of the cool thing about the halogens, they're all pretty much they're all poisonous in the gas form. So I don't know about fluorine, but I know chlorine is. Bromine I was working with one time, and it kind of got some liquid in a bag, and I took it out and was cleaning it up, and I didn't have gloves on, and my face started itching. And it was from the fumes that were coming out. So the fumes were reacting with my skin as they were.
So will you be working with any of that?
No. No. These are the elements when you write them. Now, why am I bringing this up? It's because when you write a chemical reaction out, and the reaction says, I'll do this next part, and I'll come back to this page, okay? But if I do a chemical reaction, and I'm writing it out, might not be able to because I can't find my pen, but that's okay. If I would write it out, if it said chlorine, I would write Cl2 for it. If it would say oxygen, I'd write O2 for it. So I would make sure to write out every time I'm given the name of one of these elements and it says oxygen or hydrogen or chlorine or fluorine, I would write out F2 or Br2 in that way. So this would be, for example, if I had, just don't write this out, but if I had, for example, magnesium metal, you'll have to do this in the future, reacts with hydrochloric acid, to produce magnesium chloride and hydrogen gas. Okay, again, you don't have to write this out, but this is what you would do. You would go, all right, I'm going to write this reaction out in a chemical equation with just symbols. So there you go, magnesium. It's not diatomic. It's not one of those 7. So I'm going to put magnesium. And an S for solid. It's a metal. Okay? Reacts with hydrochloric acid. How many can tell me what hydrochloric acid is?
Cl2.
HCl. Okay? Then we'll put an AQ for that, meaning it's aqueous, which means it's a mixture of water and HCl. So aqueous means it's a mixture, usually water is your solvent. Okay? Then we would draw the arrow. Then we write magnesium chloride. We know magnesium is +2, chlorine's a -1, so my formula is what? NgCl2. Now, for right now you don't know it, but this would also be aqueous plus hydrogen gas. So how would I write out hydrogen gas? H2. And then I would have to balance that. Make sure it's balanced. So Mg, there's 1. H, there's 2. There's 1 here, but 2 over here. And Cl, there's 1 here, but 2 over there. So I have to put numbers in front at this point to balance. Because I need to show I've got 2 of these HCl's. And that 2 is a multiplier. And it multiplies through the H, and it multiplies through the Cl. I got 2 of each now. So now it's balanced. Okay? I'm kind of getting ahead of myself because we're going to do some practice on balancing here in a second. But you see hydrogen has to be written as diatomic. You can't just write H.
Gotta be 2.
Yep. Like pairs of shoes. Got to be 2 of them there for them to work. Okay. This formula up here should be familiar to you, right? Or this equation. It's really important to us. If we don't do this, we basically will die. We can't do that. Our bodies can't do that. Cells can't do that. We're not going to live very long. So what's this called? Cellular respiration. Or respiration. Okay? What I'm going to do is I'm going to give you an accounting system. Okay? Accountants like to balance their spreadsheets, debits and credits. Want to make sure they're the same. We're going to make sure they're the same. Okay? This is an easy balancing. Okay? Part of that. Only we don't have dollar signs, and they're all whole numbers. That makes it easy. We don't have any decimals or anything. They're all whole numbers. So what I'm going to do is I'm going to write down each element that I have on the reactant side. So I have 3 elements, carbon, hydrogen, and oxygen. And I'm going to do the same thing on the product side. I'm going to write 1 of each. Well, just the symbols of each. Okay? Here's what we do. Now, you don't have to use this method on every single one, but some of these that are a little bit more difficult, like this one, this would be a pretty tough one to balance, especially to begin with, but it's a good one to kind of show you some little hints of how you would go about balancing it out. So carbon, we would count them all up. 6. Hydrogens, 12. Oxygens, we got them in 2 spots. 6 and 2 is, we have 8. Right? We have 6 here and 2 here. Now this brings up a hint that if we've got elements in multiple spots on each side, we will want to leave those to balance at the very end. We don't want to mess with anything that have multiple locations for that element. And here it makes it even more complex because we got 2 locations on the product side and 2 locations on the reactant side. It makes it, you can't really look to balance that out before you do carbon and hydrogen. So we got carbon, we got 1, hydrogen we have 2, oxygen we have 3. Okay. Got to count both spots for oxygen. So we're going to leave this here and do this at the very end. I'm not going to mess with it. We're going to focus on carbon and hydrogen first. So how would we balance out carbon? We got 6 here and 1 on this side. 6 in front of the CO2. That means we got 6 molecules of it. So these numbers out in front represent molecules, or atoms if they're a single element. Okay? They can also represent moles out in front. So I put a 6 in front of CO2, that could be 6 molecules of CO2, or if I'm talking about the unit moles, that could be 6 moles of CO2. Okay, which is just a bigger number of atoms. So we take this one and we multiply it by 6, we get 6. So they balance. They're good. Now I'm not doing anything with oxygen because it's in 2 spots. So now if I counted oxygens, I'd have 6 and 2, and I have 13. If I want to put 13 down here, I can. And I know it's going to change because my hydrogen, I'm going to balance next. So how many hydrogens do I have? 2. This I had 12, here I had 2. So what do I need to multiply this by to get 12? 6. So I multiply by 6. That becomes my coefficient. Coefficients are the numbers that go out in front. So now if I count up my oxygen, which I can do because now I've got numbers set in front of both of those, and I count them up, I've got 12 and I've got 6, because that 6 multiplies through 1 oxygen, and I have a total of 18. Every C, 18. Now you take a look at it. So the numbers that are coefficients out in front, they multiply through the subscripts, all the way through. So I've got 12 here, and I've got 6 here. So those two add up to 12. Okay. So then what do I need to put in front of O2 is what I want to do. I can't put a number in front of this one because this is set as 1. So the only one I can change is the O2. So I've got 6 oxygens here. What do I need to put in front of O2? To add up to 18. 6. Have you seen that before, that formula? I'm sure you have when they give you cell respiration or photosynthesis. They'll do it in this form.
So you add the oxygen?
If they're in 2 different locations, then it's just like this plus sign saying you need to add them. So here we have 6. This is 6 times 2, which is 12. So what this says that if I got 1 glucose molecule, it requires 6 oxygen molecules, and then we always produce 6 molecules of carbon dioxide and 6 molecules of water. Okay. I'm going to go ahead and give you a sheet, which you're going to have a lot of time to practice because we're going to go about 5 more minutes. Discussion. We're going to look at 2 of these on here and give you some helpful hints of how to do them, and then let you work on them. When you get it, we're going to look at problem number 14. So we'll kind of skip around. Problem number 14 when you get it. I need to make a couple copies real quick. That's not made enough. Hey, what we're going to do, give me 5 minutes, we'll be done. What we're going to do is show you some helpful hints. So we're going to go ahead and do like we did before. Again, you do not have to show this on every single one you do. But if it helps you balance them and get them right without taking too much time, eventually you might want to start doing this in your head to where you're counting in your head as you go along. I think most of you will get to that point where you can count. You see silver's balance, so why even do that? You know that chlorine's balance. Okay, that's fine. You notice that oxygen is the only one that doesn't balance. When you have a 3 and a 2, or an even or odd, you need to find a common denominator you can get both of them to so that they can equal. So in the past we've dealt with a 3 and 2. What number do we need to get both of them to? 6. So we multiply the oxygen here by 2 to get 6. Multiply this oxygen by 3 to get 6. Those become our coefficients, what we multiply by. What's underlined there? So that 2 would go in front of AgClO3. And the 3 would go in front of O2. And now the oxygens are balanced. Yeah, so then what happens a lot of times, you have other symbols change in their amounts. And if you would keep track of AgCl on the left side, you realize you multiply both those by 2 as well. And they become 2 of each. So then on the right side, you have 1 of each. So you put a 2 in front of AgCl. And you balance.
Why don't you multiply that side by 3, the other side? Like, how did you get to multiply by 2 on this side, but then on that side? Not for the O, but for the Ag and Cl.
This here?
Yeah.
Because I put a 2 out in front,
Yeah.
that multiplies my 3. It also multiplies how many Ags and Cls I have.
Alright, but then how'd you get 2 on the other side?
Here?
Yeah.
Because since over here I had 2 of each, and here I just had 1 of each, then I needed to make sure that I showed I had 2 of each one of those. So because I have 2 out in front, my oxygen's balanced, that changed my silver and chlorine to be 2 on the left side, and I only had 1 of each on the right side to begin with. I only had 1 of those. So then I have to realize I got to put a number in front of that to get 2 of each. So I put 2 multiplied by 2. A lot of times you'll come up with ones that are even and odd that you're going to have to deal with maybe right away. Once you do, it makes the other ones easier. Well, you have to in this one because Ag and Cl, they balanced anyway. Okay. The next one that, again, some of you don't have the balancing sheet, but the next one I'm going to do is number 3. So I want you to look at number 3. Okay, you can go ahead and write that out. I'll give you time to do that, and after this one, I'll let you guys work on the balancing sheet, because this is the last one I'll go through.
What number is this?
This is number 3.
Oh. Okay.
There's a little key, a little hint that'll help you on this one, and it is the following. Anytime you've got polyatomic ions, like NO3, or anything off your polyatomic ion sheet, that's shown within a formula on either side or both sides, then don't split up your oxygens and your nitrogens. Don't split them up. Don't say I've got 6 oxygens and 2 nitrogens and list them separately. The way you want to list them out is Al, Pb, and then NO3, all as one. And then on this side do the same order. Al, Pb, NO3. So then when you set this one up to balance, you will have 1, 1, 2, and 1, 1, 3. Okay, then we got that even odd again, but with a polyatomic ion. So go ahead and balance that. See if you can balance it based upon what we did on. Alright, so look at this one. And you guys just need to practice them. Just like anything, you need to practice and recognize certain trends that are happening, like even odd, like polyatomic ions. Here, you multiply this by 3 to get 6. Alright, so the lead, okay, we're multiplying by 3 as well. So this becomes a coefficient out in front of PbNO3. So 3. And then this becomes a coefficient in front of the AL and O3. So now we have 6 of both of those. The 3 makes it 3 leads. And here, the 2 in front makes it 2 aluminums. So then at that point, you go ahead and finish balancing. So all you have to do is put a what in front of aluminum? 2. And then 1 in front of lead? 3. And you're done. Those singletons, those ones that are single elements, leave to the end. And everything should balance. Okay? Alright. Just go ahead. Now some of these could be balanced that are on this sheet. Some of them may not be balanced.